Okay, so welcome. Now we'll get on to the last example here, which is simplifying complex fractions. So basically what you can see in all of these examples is we basically have like fractions within fractions, except for this example. But actually you have this. You have a fraction in the numerator, fraction in the denominator. But here you can see a lot of these also are separated by addition and subtraction. So there's a couple different ways that we can go about this. And I'm going to really kind of work on both ways so you can kind of see the difference and see which one works best for you. However, I do have two examples where there is no addition and subtraction sign. And basically, if you think about that, that's really just taking a fraction and dividing it by another fraction. So for instance, that's just like, if I had, let's put over here, like 1/4 divided by like 3/4, right? Well, remember, if you have a fraction divided by another fraction, the main thing we want to do is get rid of the fraction in the denominator, and we can do that by multiplying by the reciprocal. Let me just zoom in here. So if you multiply by the reciprocal on the top and the bottom, and this is something we talked about with the dividing of fractions, then that multiplies to give you 1, and this multiplies to give you 1/3 over 1, which just can be written down as 1/3. So in this example, in A, you can see we really just have a fraction divided by another fraction. So that's basically what we're doing, is just dividing fractions. So therefore, to simplify this, we're really just going to multiply by the reciprocal of the denominator. But before we go ahead and do that, we want to go ahead and simplify this. And I see here that this 4 minus x squared doesn't look very pretty. So I'm going to rewrite this as a negative x squared plus 4. Okay, and by rewriting that, I can see that, well, that's not going to help. I can't factor that. Like here, I can see that's a difference of 2 squares. This I can see is not as far as a difference of 2 squares. However, if I factor out a negative, then I would left with x squared minus 4. And now you can see it's just like my numerator up here, where I can go ahead and apply the difference of 2 squares. So I'm going to go ahead and factor this numerator. I'm just going to write my problem here down below. So the numerator, this can be factored into x minus 2 times x plus 2 divided by 4x. And then rather than showing all this work here, I'm just going to multiply here by the reciprocal, which would be a 2x squared, and then divided by a negative, and now I will factor the x squared minus 4 out. So that'd give me an x minus 2 divided by x plus 2. Okay. Now we could rewrite this all over as one fraction, but we notice that everything is just being separated by multiplication. So now I can go ahead and apply the division property. So here we have an x minus 2 divided by an x minus 2, which goes to 1. An x plus 2 divided by an x plus 2 goes to 1. We have a 2 over 4, which can be reduced to a 1/2. And then we have an x squared divided by x, which you can see that x squared, or x divides into x squared one time. So therefore, my final answer here is, let's see, I'm going to have a 1 left over there. I'm going to have an x to the first power. So let's go back in purple. So I have an x to the first power all over 2. And then there's times a negative. Everything else got divided out. So that's going to be a negative 2. So there we go. That is now simplified. Now you don't need to write the 1 in front. And you could also rewrite this as, a negative 1/2 x would be another acceptable answer there. All right. So then what do we do when we have, we only talked about multiplying. Yeah, we talked about, okay. So when we're looking into an example like B, you can see that we have some addition subtraction. And you can see that once we get it, if we get it to a fraction divided by another fraction, we just multiply by the reciprocal of the denominator. So to get this fraction to that point, basically what we need to do is combine our fractions. So that's one way. So this is like option number 1. So for this one, I'm going to do option number 1. Okay. And you could do either one of our options for any of the problems. I'm just going to show you both methods. Because what I want you to think about there is if we can combine the fractions in the numerator and combine the fractions in the denominator, then I can just apply this process. So basically what I'm going to do is get common denominators for my denominators in the numerator and get common denominators for my denominators in the denominator. So here you can see I have 4x and then x squared. So that means my LCD is going to be least common denominator in the numerator is going to be a 4x squared. Let's put this over there. Okay, so therefore to get this to be an x squared, I'm going to multiply by an x over an x. Remember, you got to make sure you multiply in the numerator and denominator to keep equivalent fractions. For this fraction, I'll need to multiply by 4 over 4. Okay. Now the denominator doesn't always necessarily have to have the same LCD, but in this case it does. So therefore I just need to multiply in this case by 4x on the left and the right side. So if they don't have the same LCD, then you'd have to do the same process. All right, so now I go ahead and multiply everything through, and I'll get a x over 4x squared plus a 8 over 4x squared all over a 4x over 4x squared, and then minus a 2 over 4x squared. Okay, now I can go ahead and now combine my numerators. Now I don't have like terms, but I can at least combine them under as far as one fraction. So I'll have x plus 8 divided by 4x squared all over 4x minus 2, which I could simplify that, which I'll do next. 4x minus 2 divided by a 4x squared. Okay, now we're back to what we did over here, which is as far as having a fraction over another fraction. So therefore, I can just multiply by the reciprocal. So again, if you want to think about this as writing it as, 4x squared over 4x minus 2. Don't need to do this work, but I'm just showing you where it's coming into. Okay, but what I'm just going to do is I'm just going to write it as, I'm just going to take my numerator, x plus 8, over a 4x squared. I know that goes to 1, so it's going to be times a 4x squared divided by 4x minus 2. Now, I could have factored that out, but what I realized is it's not going to simplify anything. So we'll just leave it in the unfactored form. You can see these terms are exactly the same, so they're going to divide out. And therefore, my final answer is just going to be an x plus 8 over 4x minus 2. All right, let's go on to the next example. So the next example you could do, well, I could get common denominators over here. I could rewrite these as, fractions if I wanted to, and then get common denominators. But I want to give you a different idea. And the different idea is rather than finding the LCD and combining the fractions in the numerator and getting the LCD and combining the fractions in the denominator, let's just find the LCD of every single fraction that we see and then multiply every single fraction by the LCD. And so what that's going to do is when you multiply by the LCD, rather than trying to obtain the LCD so you can combine them, if you multiply everything by the LCD, you're going to eliminate the fractions or eliminate the denominators. And that's basically our point. We want to eliminate the fractions in the numerator and the denominator, so we just have one fraction. So in this case, I see that my denominators are 1, x minus 2, 1, and x minus 1. So I can say that my LCD of all these fractions is just going to be the product of these two denominators, which would be an x minus 2 and an x minus 1. So what I'm going to do is I'm going to multiply everything by the LCD. Okay, so you have to be careful. You are applying you're basically applying distributive property to each and every one of these, okay? The power to quotient rule. Basically, you're distributing here to the numerator and denominator to all the terms. So if I multiply x minus 2 times x minus 1 to 2, then I'm just going to have 2 times x minus 2 times x minus 1. If I multiply it times this fraction, the x minus 2's divide out, and I'm just going to be left with minus x minus 1. Notice how I don't have any more fractions there. Here, I'm going to multiply this. It's going to give me 2 times x minus 2 times x minus 1. And then over here, the x minus 1's will divide out, and I'm just going to be left with that's a plus, 3 times x minus 2. Okay, now technically let's go ahead and simplify. Now we might want to see how that is going to, what that would simplify by. So I'm going to multiply x minus 2 times x minus 1, see if that might be, now this would be perfectly fine. It's not really in a simplified form, but let's go ahead and distribute these and put them in standard form, kind of see what that looks like. So this would be a x squared, x squared minus 3x plus 2. Okay, so I'm going to do a little bit of work here. So that goes to there. So if I was going to distribute a 2 to that, I would get a 2x squared minus 6x plus 4. So basically what I'm doing is I'm multiplying a 2. So you can see that product is right there. So I'm multiplying it by 2. Let's distribute this x, negative x minus 1. And then in my denominator, here, I'm going to multiply by 2 again. So therefore, that's a 2x squared minus 6x plus 4. But then I'm going to be adding a 3x minus 6. Okay, so now I can kind of combine like terms here. 2x squared, let's see, that's going to be a minus a 7x. And let's see, that's going to be a plus 3. And then down below here, I have a 2x squared. That's going to be a minus 3x, and that's going to be a minus 2. Okay, now potentially these could be factorable, and then we could potentially go ahead and still simplify these down. So basically what I'm going to want to do is see if I can continually factor these out. And this is a kind of a heavy problem here. So let's see if these can be factored out. Fortunately, they can be just be factored into 2 binomials, which is nothing crazy, at least with the 2x and the x. And so here I see I'm going to be doing a sum, and I'm going to want to add these. So this one can be factorable here. Both my terms are going to be negative. So let's see if I did a minus 3 and a minus 1. So negative 1 times negative 3 is a negative 3. Negative 2x times negative 3 is a negative 7x. Or negative 6x. Negative 1 times x is negative 1x. Negative 1x plus negative 7x, 6x is negative 7x. All right, here is going to be a difference, and we need to find the difference of 3. So I'm not sure if I can, so let's see here. I'm going to have 2 and 1. That means one's going to be negative and one's going to be positive. So let's see if I did, this would have to be a minus 2, and this would have to be a plus 1. So let's see if that works. That's 2x squared. That becomes a negative 2. That's a negative 4x, and that's a positive 1x. Okay, so I get everything simplified, but you can see that it can't be simplified any further. So either form, the expanded form or the factored form would be acceptable. But I'm not seeing any issue with my factoring. So it looks like that is it. All right, so in this next example here, same exact thing. Now, what we're going to want to do is just go ahead and rewrite this as a, you can see we have a fraction divided by another fraction. So we're just going to rewrite this as a product. So this is the same thing as, x squared over x plus 1 times x plus 1 cubed over x. And, if when you have x squared divided by x, we know that x divides into x squared x times, right? Well, this is the same thing. We just have this as an expression. You can think of it like, treat it as like an x dividing into an x cubed. So, it's the same thing if this was just a variable like y or x or something, but in this case, it's an expression. So what we can see here is x divides into x squared one time, and x plus 1 divides into x plus cubed 2 times. So therefore, my final answer here is, let's see, I'm going to be left with a x times a x plus 1 squared. And no denominator. You can see the denominators both divided out. All right. So the next one is, again, you can see we have this adding here. And again, we could combine these fractions and then divide, but I would just like to say, well, what's the LCD here of these two denominators? And of this one as well, you can put these as over 1. And I can see that the LCD here is just going to be 2x. So let me go back to purple. So LCD is equal to 2x. So again, I'm going to multiply everything by 2x. Everything. Okay, so when I do that, up top I get 2x squared plus 4x. In my denominator, my 2's are going to divide out, so I'm left with a x squared, and here my x's divide out, so I'm left with a 4. All right, and now we can see, let's just do a little simplifying, see if there's anything really we can do here. Well, there's not really much I can do in the denominator because that's an x squared plus 4. So that's not factorable by difference of two squares because it's not a difference, it's a sum. And that gives me a 4x. So let's go ahead and factor. I mean, I can factor out an x from my numerator to get this a little simplified, but it's not really going to be improving this. However, what I see here, no, that gives me, oh man, I wanted that. So that gives me a 2x. It gives me close. If I factor out a 2x, I'm going to be with the left with an x plus 4. Oh. And then this would be a x squared plus 4. So it looks like they'd be factored out, but again, these are not exactly the same, so they would not divide out. There's nothing really else we can do here, but I just want to check to make sure that 2x squared, and that's a 4x. So that would be just double checking my work. The 2's divide out. That gives you an x squared. And that gives you a 4. Yeah, cool. So nothing else really we can do. I don't know why I have this extra parenthesis. All right, let's do in this last one. So this last one, you can see we have a lot of different denominators here, right? And so what I notice is rather than finding the LCD just being the product of all the denominators, always look to factor anything anytime you can. And what I notice here is 2x squared minus 2, I can factor out a 2 here. So when I factor out a 2, I'm left with an x squared minus 1. Well, that can be further factored down into x minus 1 times an x plus 1. So what I notice is that is what these two denominators are. So the only thing else that I need to add here is just this 2. So if these all had a 2 as well as an x minus 1, x plus 1, that'd be my LCD. So the product of basically all of these, they already share these two, but it's just going to include a 2. So 2 times x minus 1 times x plus 1. Okay, and again, you could combine these fractions if you wanted to, but I'm just going to multiply everything times the LCD. So therefore, I'll have a 2 times x minus 1 times an x plus 1. Okay, multiply everything times that. And when I do that here, when I multiply this case, my x minus 1's divide out, so I'm left with a 2 times an x plus 1. Over here, my x plus 1's will divide out, so I'm left with a plus a 3. Oh, that's times a 2, right? There's an extra 2 there. The x minus 1's divide out, so you're left with a 2 times 2 x plus 1. And this would be plus 3 times 2 times x minus 1. And then you can see here, my denominator is exactly the same here, so those are divided out, so that's just going to be left divided by -1. So basically, all I got to do is really simplify this and divide each of these expressions by a -1. So what I'm going to do is I'm going to factor out this -1 here on the outside. I'm just going to put it out in front, and therefore I can simplify this. So this would be a 4x plus 4 plus a 6x minus 6. Let's combine our like terms, 10x minus 2. And now I'll just distribute this negative to give me a -10x plus 2. And that would be your final simplified expression. So there you go, ladies and gentlemen. That is how you simplify complex numbers. Basically, again, to review, there's a couple different ways. If you have just one fraction over another fraction, you're basically just multiplying by the reciprocal. If you have addition and subtraction separating your fractions, then you're either going to want to combine the fractions in the numerator and the denominator, or my preferred method, it would just be multiplying everything times the LCD. And usually the LCD most commonly can be found by just multiplying the denominators. However, be careful because sometimes they have common denominators already within them, so you're not going to want to multiply every single denominator you see, but just find that common denominator. So there you go. Hope you enjoyed.